Welcome. In this video, we want to see how we can apply differentiation to find and classify stationary points and inflection points where possible of the following functions. So, when you are taught to find stationary points, the first thing that you have to know is stationary points happens where the derivative or the gradient function is equal to 0. So when the gradient function or when the gradient is equal to 0, that's when we have what we call stationary points or inflection points. Sometimes they can be called critical points. Now we have three types of critical points or stationary points. One, we have a maximum, minimum, or point of inflection. The point of inflection is sometimes called the saddle point. So the first thing that you have to do, you have to find the gradient function, which you have to equate to 0. So in our first question, which is a, we have a function f of x is equal to x squared minus 4x plus 5. So the first thing that we have to do here is to find the gradient function, which is f prime of x is equal to, when we try to differentiate this one using the sum and that one we had. So we have this for the gradient function. Now, at the critical points or stationary points, the gradient function is equal to 0. So we equate this to 0. So our 0 is equal to 2x minus 4. From there, we have 2x is equal to 4. Then now we have x equal to 2. Now, since we are finding the stationary points, we have to find the y value or the f of x at this point where we have x is equal to 2. So if I try to replace 2 in this particular function of something like this, so f of 2 is equal to 2 squared minus 4, 2, 5. Here I'll get 4. 4 minus 8 plus that, I'll get this equal to 1. So the critical point is at x comma y. The x value is this one, the y value is that one. So we have 2 comma 1. So this is the critical point. Now we have to find the nature of this particular critical point, or in other words, we have to classify it. It can be a minimum. It can also be a maximum, or it can be a point of inflection, which we also call the saddle point. Saddle point. So the minimum looks like this one, the maximum looks like that one, the saddle point looks like that. So this point here is what we call the saddle point. It can also be the other way around. Now, we have the minimum when the second order derivative is positive. If it is a maximum turning point like this one, the second order derivative should be negative. If it is a saddle point, we get a 0. Okay, so now we have to find the second order derivative of this one for us to classify this particular turning point, which is this one. So I will find the second order derivative. So f double prime with respect to x is equal to 2. Now when you look at this, which sign is this one? You can clearly see that it is positive. So we have what we call the minimum turning point. So we can say therefore this one is a minimum turning point. Okay, now every time you are given or you are asked to find the stationary points or the critical points, the first thing that you do is find the gradient function, equate it to 0, find the value for x, then replacing the actual function, find the value for y, then have the point, then test the actual point if it is a minimum, maximum, or saddle point. Now what will happen is for a minimum, the second order derivative will be positive. If it is a maximum, it will be negative. If it is a saddle point, it will be 0. This is what we call the second order derivative test. So sometimes they will tell you to say, use the second order derivative test, then you have to use this particular concept. Sometimes you can just check the neighborhood for this one and predict if it is a minimum, maximum, or saddle point. Okay, I will discuss that one in the next videos. Okay, so now we go to B. Again, we use the same procedure. We are going to find dy over dx, equate it to 0, because that's what happens at stationary points. From there, we'll calculate the value for x or the values for x. So you should always take note that we are not always going to have one point. Sometimes we have many points as turning points. Okay, so now let's see what happens in B. So in B, we have to differentiate. We find the gradient function. We have to differentiate, find the gradient function, equate it to 0, solve the value for x, of which that particular gradient function is 0. So here we have B, y is equal to x3 plus 3x. So y prime is equal to, this will be 3x squared plus 3. Now, at the stationary points, the derivative is 0. So if I try to equate that to 0, I can divide throughout by 3. I'm going to get 0 is equal to x squared plus 1. Here I have x squared is equal to negative 1. So we have to find the value for x and not x squared, so I introduce square root both sides. But whenever I introduce square root, this should read positive or negative. So what we are going to have is, we are going to have this. We are going to have x is equal to plus or minus square root of negative 1. Now square root of negative 1, square root of negative 1 is an imaginary unit I. If I try to square, I can see negative 1 is equal to I squared. Okay? There is, in the real system, there is no square root of negative 1, so we imagine there is such a number and we call it an imaginary unit I. But if you square both sides, you have this, so I can use this identity to simplify wherever I have I, or wherever I have something like that. So this will be x is equal to plus or minus I. So the critical points occurs at x is equal to I, or, and, should I say, and x is equal to negative I. Now we have to find the value for y at this point and the value for y at that particular point by replacing in this particular formula. So at this point, you can say f of I is equal to I to the power 3 plus 3I. So this will be I squared multiplied by I plus 3I. This is negative, so I'm going to get negative I plus I, which will be 2I. Then I'll come to where x is equal to negative I. So after we find for this one, we go to x is equal to negative I. We are going to put negative I in the original function so that we can find the y coordinate. When we do that, we are going to have this, which will end up giving us this. Okay? Now we have to test if this is a maximum or minimum. We also test that. So we are going to use the second order derivative test. So if you try to differentiate this one twice, you get y double prime is equal to 6x. So if I try to put x is equal to I, I'll get this one, which is positive. If I try to put negative I, I'll get this one. Now, when I get a positive, it will be a minimum turning point. When I get a negative, it will be a maximum turning point. But if I get a 0, it will be a saddle point. So this is not the only way in which you can test. You can also test the neighborhood for this one and that one, then you can determine whether it is maximum or minimum. I'm going to do a video on how to do that. So for this and more videos, subscribe to my YouTube channel. Thank you very much for watching.